I'm super excited because this week I'm at the Derby Canyon cabin and completing two major milestones for projects that are really helping us to take our off-grid living to the next level here in the Derby Canyon. So this cabin is kind of my headquarters for learning and trying new systems and products and things that help us live in a net zero fashion, which the end goal is to create a community where we produce our own water, food, and power. And so we're looking at the power and water components this week. So I've got the components of a system that I'm going to be setting up, which is both a solar energy installation. So we're going to have four of these thin film style panels. Now, I'm going to hesitate on giving any product reviews or anything like that since I haven't used any of this and since it could be just cheap and low quality, but I will say I definitely opted for more cost-effective, if you will, items, and so I'll certainly be doing a follow-up video in the next year or so after we have a chance to put these systems through all the ringer. So this solar energy system is four 1,000 watt panels. Now, I'm a little skeptical that they're actually 1,000 watts. That's a pretty efficient panel, and for the price and all that, I'm not 100% sure if they're not maybe over-suggesting on what they can actually put out with the standard testing conditions. However, in an off-grid system, what's far, far more important is how you size your battery and your capacity. That's something that I created a different video on, and I'll put a link in this description so that you can see exactly how to size batteries, because that's an extremely important calculation and skill, especially if you're going to depend on that system for living or just recreational use like we do here. What I ended up calculating for using our heat pad, which, by the way, this entire system came about due to the need and desire of having running water in the cabin, but the challenge of being unoccupied for months at a time in the winter when it could literally be below 0 degrees up here. This cabin's at 3,000 foot elevation in the Derby Canyon. So instead of just allowing the water to freeze and potentially cracking lines and creating failures and bigger issues in the seasons when it's melted and creating flooding and that kind of thing, I'm opting for the strategy of using a heat pad to keep the holding tank warm consistently and never allowing that water or tank to reach freezing levels. Now, this is all experimental for me, but in theory, it should all work really well. This is a 13.5 volt DC 65 watt heat pad, and this was part of the calculation, making the assumption that this is going to be drawing 24/7, which really it shouldn't be. So that's already starting with a conservative calculation of figuring out what size batteries do we need given our energy input. And again, all the details in that are in that separate video that I'll go ahead and link for you to reference. But the most important thing here to understand is that we have 200 amp hour batteries, which should get us several days without additional charge powering this heat pad. And the other thing that they will do is power this water pump. Now, this is all DC. So we have a water pressure pump here. This one, I believe, is just 12 volt. This is a 12 volt, 8 amp RV style water pump. And the whole purpose of putting a water pump in here is instead of doing just a gravity fed system where I could just literally run lines with this tank being high enough here, we just have gravity fed at the sink in the kitchen and in this bathroom as well. But I really wanted to be able to filter the water and have a little bit higher quality just water experience. So what we're going to have is 4 of these panels installed outside running DC power into our charge controller, which makes sure that we don't overcharge our batteries and maintain healthy batteries and charge and all that, which will then, those panels, their entire job is to charge these batteries and keep them full or as close to full as possible based on the conditions and the amount of sunlight that we're receiving. So this DC heat pad and this DC pump will be tied directly into these batteries, and they'll just run directly off those. I also opted to get a 1,000 watt inverter. This is mainly for anything that's going to need that 120 AC. It makes it easier for charging our devices and just maybe running power tools once in a while and other demands like that. This is also going to be the way, well, actually, all of this is designed and planned for winter. Again, the main idea is keeping the water warm, pressurizing the water, and having enough power to run the heat pad and to go several days without any sunlight and to allow obviously the sunlight that comes through, even though it's not a ton of hours and not a ton of strength in the winter, to be able to keep our batteries in a healthy shape. Again, reference that other video for all the details on that. What the inverter is going to allow us to do is to plug in AC devices, do other charges, and so forth. The other thing is, in the summertime, I'm planning to utilize this system for our cooler, or AKA fridge. So when we're not running the heat pad, which obviously in the summer months would be not necessary since we're not worried about freezing, it's around a similar draw. Again, see that other detail for all the videos, to plug in my 12-volt cooler that runs kind of like a fridge. So that's going to be the plan for the summertime of how we're going to be powering that fridge slash cooler and keeping all of our food cold and at a good temperature. And then this is that water system, or I should say filtration system, that is a reverse osmosis 3-filter stage system that will be installed in this room as well. That I'll be running a line to our sink so that we have pressurized water. We'll also be doing a sink in here that will have pressurized water, and both will be filtered and safe to drink, because the thing I forgot to mention is this holding tank is going to be tied into a rainwater catchment system. So these are actually two different projects that are kind of dovetailing together. I started the rainwater system, which has a gutter out here for collection, last year, and you may have seen a video where that gutter actually got torn off in an ice storm, or at least the water that was stuck in that gutter froze and turned into kind of a giant puck, and the pine needles that were there did not help with that. That ended up tearing off the gutter, and so this week I'm going to be reinstalling that with what I hope are better fasteners, and will hopefully be preventing that issue from happening again. And then finishing, we'll basically just have a diverter here that brings water into this holding tank with a float valve. Float valves use water level to bring open a float that then closes a valve. So in theory, if I do this all correctly, we'll collect rainwater off of our roof that will be funneled into our holding tank, that will then turn off that valve every time this tank is full. So every time it rains, if we get enough water, we should be filling this tank, with the excess going to a holding tank outside. That outside tank is just for general use. I use it for mixing concrete. We could irrigate with it if we were growing food. Just having general unfiltered rainwater collection that way, since again, this is a dry cabin. So big picture for this weekend, we'll be installing rainwater catchment that brings water into this holding tank. That holding tank will then be warmed in the winter with this pad that's running off our off-grid solar system that's really depending on these batteries for all that power. This will also be tied into our water pump. There's also DC running off our batteries, which will then feed our filtration system, which will and then end up at our sinks. So we'll have filtered drinking rainwater at both sinks, and also obviously just a little bit higher quality of life for making washing easier and that kind of a thing. So I'm super excited for this project. It should really increase the enjoyment and ability to come out here and not have to bring so many supplies, and have a little higher quality of relaxation. And obviously I'll be taking you along with me. So if you want to learn how to do this for yourself, stay tuned. If you're trying to just follow a really cool project, then let's get going. My mission is self-reliance through sustainable living, and we're here to build a community. Click here to subscribe to be sure to get more awesome content for living off the land. And be sure to go in to enter for notifications. Click that bell, get notifications, and stay in tune. Subscribe, watch, and comment. Let's build a community. See you soon.